Okay, quick review of what we were talking about in class today. We are talking about solving systems of equations. That is when you have two or more equations and you find the point or points of intersection of those two graphs. We are going to be focusing primarily on linear equations, so a lot of times it'll look something like this. Ax plus by equals c, and then potentially dx plus ey equals f. These are two linear functions in standard form using 6 different letters because the numbers could be all distinct. But the idea is that we're just finding where two lines cross, and we're going to do that algebraically using two different methods, one called substitution, one called elimination, and let's review those now. So, first, substitution. Substitution is when you take one of the equations given and you solve for a variable. When I look at these two equations, there is one variable that is pretty easy to solve for in one of the equations. The other 3 variables are kind of difficult to solve for, or more difficult. Not impossible, just makes it harder. So take a second, look at the 2 equations, and see if you can't determine which equation and which variable it's best to solve for. If you said y in the first equation, you're correct. So the clue there is that the coefficient or number in front of y is 1. And when the coefficient of a variable is 1, it's really easy to solve for. I subtract 2x from both sides, and I get y equals negative 2x plus 20. Now what I'm going to do is I'm going to take negative 2x plus 20, and I am going to substitute that in for y in the equation I did not solve for. If you substitute it back into the equation you solve for, you will get 20 equals 20, and you'll be confused about what that means when you finish the video, because that can happen when you solve a system of equations, and it means something different than if you substitute it back into the actual equation you used. So now when I write this equation, 6x minus 5y, and what's y? Y is negative 2x plus 20. And now I know that that equals 12. Now I have one equation with one variable, and all I need to do is distribute the negative 5, collect like terms, and see what happens. So I get 16x equals 112, and then when I take 112 and I divide by 16, what do we get? Hopefully you have a calculator and are doing this too. You get x equals 7. Now we take that and we put this in over here, because this tells us what y is if we know what x is. So that's negative 2 times 7 plus 20. That's negative 14 plus 20, or y equals 6. So the most important idea is that I know those two lines cross at 7, 6. X comma y. The answer to a system of equations should be an ordered pair, or multiple ordered pairs if it's something like a parabola and a line. But for right now, we're just talking about two lines, so the answer is a point. So that's substitution. Again, to review substitution, the way it works, you take one equation, pick one equation, and solve for one variable in that equation. Whatever variable you solve for, you plug that in to the other equation. Once you plug that into the second equation, you now have one equation in terms of one variable. You solve that equation. You solve that second equation. You get an answer, and then you substitute back into that first equation, and you get the other variable. All right, let's take a look at elimination. Elimination is my favorite method. I think it goes the quickest. With practice, it goes pretty fast. Here's a perfect example of why we want to have a different method. If I solve the first equation for x, I end up getting x equals 9 over 7 plus 8 over 7y. Yuck. If I solve for y, I get, well, let me do this in my head. Sorry, making mistakes. I get 7/8 x minus 9/8. And those are both pretty gross. So if I had tried a different one, maybe the second equation, and solved for y, I would have gotten y equals negative 11 over, or sorry, negative 22 over 9 plus 4 over 9x. And if I solve this for x, I would have gotten 9 over 4y plus 11 over 2. All of that looks really gross, and I don't want to deal with those fractions. So a much easier way to solve this equation is to pick a variable to eliminate. So I look here, and I'm just going to have to bite the bullet, and I'm going to have to multiply this by 4 and get negative 28x minus 32y equals 36. Then I'm going to multiply the bottom equation by negative 7. When I multiply by negative 7, I end up getting positive 28x minus 63y, and then that equals 22 times 7, which is 154, or negative 22 times negative 7, which is 154. This is looking pretty gross, but trust me, it's not going to be that bad when we add everything up. Add these up and they cancel. That's why we did it. Notice the 4 and the 4, the 7 and the 7, that will always work. Sometimes you can pick a smaller number, but that one works. Add this up and I get negative 95y equals 190. Now, divide both sides by negative 95, and you should get that y is equal to negative 2. Now, once you get that, you have a choice. You can come back here and eliminate again for y this time and solve for x, or you can substitute that in and solve for x. And I think that's what I'm going to do. I don't think that'll be too difficult. So negative 4x plus 9 times negative 2 equals negative 22. That's negative 4x minus 18 equals negative 22. That's negative 4x equals negative 4. And then that's x equals 1. And so you get the point 1 comma negative 2. And we're done. Now, all of this has worked out really nicely because these two systems had a solution. Let's talk about the possibilities of two lines intersecting or not intersecting, or actually being the exact same line, and what happens algebraically. So we've talked about this case. Two lines intersect and we find their point. There is the chance that two lines don't intersect, or two lines look the exact same. And what happens in those cases? Well, it's actually pretty just that straightforward. We'll see what it looks like algebraically when we solve them. But here's the idea. You can have two lines that intersect and their solution's a point. You can have two lines that are parallel, so there's no solution. Or you can have two lines that coincide everywhere, so there's infinitely many solutions. When this happens, what we're dealing with is not two unique equations. The equations are actually multiples of one another. When we have this situation, we end up getting two linear functions with the same slope but different y-intercepts. So take a look at this system if we were to solve here. I've got 2x plus 8y equals 6 and negative 5x minus 20y equals negative 15. Let's do elimination. I am going to multiply the top equation, and this is going to be a little tricky, but I'm going to multiply the top equation by 1/2 and get x plus 4y equals 3, because that's going to help you see that I can then multiply it by 5 and get 5x plus 20y equals 15. So now when I combine this equation here with this equation here, I get 0 equals 0. Now, 0 equals 0. When does 0 equal 0? All the time. This is always true. So if you get something that's always true, like 0 equals 0, or 5 equals 5, or 7 equals 7, what you have found out is that these two lines are actually multiples of each other. If I multiply this equation by 5 over 2, I get 5 here. Multiply this by 5 over 2, I get 20. Multiply this by 5 over 2, I get 15. Multiply it by negative 5 over 2, and you get the exact same line. So if you were to graph this line, which looks something like y equals negative 1/4 x plus 3/4. So if you graph that line, both lines, and oh, that is not correct. I can't erase that. This app doesn't let me erase. Let me fix that. How do I know it's wrong? Well, it's got to have a negative slope. So if I graph this line, and I encourage you to graph this line on your graphing calculator, this is the exact same line. So better yet, I encourage you to graph both of these on Desmos, and what you'll see is that you get the exact same line. So this has infinitely many solutions. And I forgot to close my email program, so you probably just saw that or heard that I got an email. So sorry about that, but anytime you're solving a system, if you get something that's always true, that means there's infinitely many solutions. This is why when you use substitution, you have to be extremely careful that the equation you solve, you substitute into the other equation. Otherwise, you're going to end up getting 0 equals 0, and you'll think that this is the case when really you just plugged into the wrong equation. Let's take a look at a different system. Try to solve this algebraically. I see that there's a negative 3x here and there's a negative x here, so I'm just going to multiply this equation by negative 3. And I get 3x minus 3y equals negative 9. I now add that up with the first equation, and I get 0 equals negative 5. Now, when does 0 equal negative 5? 0 equals negative 5, never. This is never true. 0 will never equal negative 5. So what's happening in this system is that one of my equations, so if I graph this one, it's y equals x plus 3. If I graph the other equation, it's y equals x plus 4/3. Y equals x plus 3 looks something like this. Y equals x plus 4/3 looks something like this. So what has happened here is I end up getting two parallel lines that never cross. And because they never cross, I get a statement that's never true. So this system has no solution. So if we go back to that graphic at the very beginning of this discussion, not the beginning of the video, if we go back to this, the possible cases is that you get a solution. We call this consistent, and we say that the lines are independent. If there is no solution, we say this is inconsistent. And if they're the same line, we say that it's dependent. So these lines are inconsistent. They're also independent, but they're inconsistent. It's an inconsistent system. This is a dependent system. The solutions actually depend on the line itself. There's an infinite number of solutions, and they all depend on what that line is. This is inconsistent because we have these two parallel lines that never intersect. And then the one that we've looked at the most, consistent and independent, two lines cross. All right, Short video. Enjoy Lessons and Carols, or I hope you enjoyed it. Thanks for listening. Have a great night. I'm going to give a pop quiz tomorrow for those of you watching the video, and the pop quiz will ask you to list the 3 systems and the picture. So it will be open note, and you can have this picture drawn in your notes, and I'm just going to ask you to copy this picture down with these terms to prove that you watched the video. But also, I want you to say one solution, no solution, infinitely many solutions. All right. Peace.